work being done on an object. If I have an object that has forces acting on it, the applied force or the push or pull acting on the object at an angle, this is going to change because only part of that force is actually doing work on the object. The force that's acting in the same plane as the motion of the object. Okay, in order to determine this, I'm going to draw a free body diagram. Here's my object. It is going horizontally along a surface. However, the force of the pull is at an angle. This is the force applied. The angle that it's being pulled at is to the horizontal. Friction is not on an angle because the surface is flat. The friction deals with the actual surfaces that the object is coming in contact with. Okay, so therefore the angle does not apply to the force of friction. The object, we know, is traveling some delta x, right? And it's traveling forward. Now we can determine how much work is done by the applied force. The work done on an object is determined by the force times the displacement times the cosine of the angle. Now, why is it a cosine? If you look at the picture, you'll notice that the angle is adjacent to the horizontal component of the applied force, what we call FAX. So, in order to get the appropriate amount of force that's being applied in the horizontal plane, meaning in the same direction as the motion of the object, I take into consideration the cosine. I know the force applied that's given to me. I have a delta x and I have an angle. So, to find the work done by the applied force, plug in the appropriate information. The applied force is 400 newtons. The displacement is 10 meters. The angle that the object is being pulled at is 40 degrees. Now all you have to do is multiply. You can do this another way. You are able to find the force that's being applied in the horizontal direction and then multiply it by the displacement. It's basically doing the same thing that you're already doing, just in 2 steps instead of 1. Okay, so 4,000 times the cosine of 40. $3,064.2 if we round to the nearest 10 joules. Okay, now I want to find how much work is being done by the force of friction. Friction, we know, is always opposing the direction of motion. In this case, the force of friction is going to be 120 newtons. That's the magnitude. Okay? When you do the work done by friction, you take the force of friction multiplied by the displacement, multiplied the cosine of 180. 180 represents the opposite direction of motion on a flat surface. Okay? The direction of motion is to the right, so 180 degrees is to the left. All that does is make the work negative. That's what you want. You should have a negative work whenever you're finding the work done by friction. You're using the same displacement. The object is still traveling 10 meters. Okay. Now, you have both the work done by the force applied and the work done by friction. Now you can find the net work. The work done by the applied force plus the work done by friction. That will give you the net work. Remember, net means the sum of all of the works done. There is another way to solve for the net work. You can find the net force first and then find the net work. When you find the net force, please make sure you're using FAX and not just FA.